Sorry, you hear that bell in the video, but anywho, we're going to talk really quickly about volume. The last video is about mass, and that's how much matter is in an object, and that will not change no matter where that object is. But we're going to move into volume. This is the second component of density, because I did tell you we will talk about density, but for now, just remember that density involves both mass and volume. So we need to have a little bit of a background on volume first. We're going to watch this really quick video, and then we'll kind of go into how you calculate volume. There's going to be two ways. Many of you guys have heard of length times width times height. That's one way. And then there's going to be another way that will be mentioned in the video, and we'll kind of go over it when it's over. So let's go ahead and watch this.
Volume is the measure of the amount of space an object takes up. In a fish tank, we can find out what takes up more space, the rack or the filter. We need to measure the volume of both objects. To find the volume of the filter, we use the formula. Volume equals length times width times height. Using a ruler, we take measurements. The measured value for length is 5 centimeters. The width is 5 centimeters, and the height is 5 centimeters. Our calculated volume is 125 cubic centimeters. The shape of a rack is described as an irregular solid because it is not made up of simple shapes. As a result, we need to find the volume of the rack in a different way. To find the volume of an irregular solid, fill up a beaker with a known amount of water. Then, drop the rock in. Notice that the water level is higher. The movement of water is known as displacement. The amount that the water moved is 25 milliliters and is also the volume of the rock. Everything that takes up space in the fish tank has a measurable volume. If you were to enter the tank, think about how much water would be displaced. That's your volume.
Alright, so what you guys heard in that video was that volume is the amount of space an object takes up. They gave you some examples in the video, but a couple more examples if you think about it. Have you ever filled up a drink of like water or juice or something, and then you put ice cubes in it after, and then all of a sudden like it overflows or something? Yeah, that's a good example of volume. Then another one could be like you have a bathtub and it's filled up with water, and you got in it and sat down. Then the water rose up because your body took up space. Those ice cubes took up space in the cup, so therefore that water was displaced then, and yeah, that's volume. So in that video, you guys learned that in the past, I know from other kids in other years, you guys know that if you have a square or a rectangle, that's what's known as like a perfect solid. You guys know to do length times width times height. Okay? That is volume. That is volume of a solid, a regular object, such as a square or a rectangle. It could even be something known as a cube. Okay, you guys have seen cubes. I know a lot of the kids last year loved Rubik's Cubes, and that is what's known as a cube. It's going to be perfect on every side. So every side will be the same length, the same width, the same height, and you multiply those three together and you get an answer. Now, your answer typically in 6th grade we use centimeters. I mean, you might have an instance where we use meters, but typically it's going to be centimeters. And since we're multiplying together length, width, and height, you're going to have a 3. So you'll have your answer, and then you'll have CM3 behind it, okay? So that's how you find volume of a regular object of perfect solid, okay? Sometimes known as a perfect solid, like a cube. Now, the one we're really going to focus on right now was in the video. It's kind of the examples I gave you, and it's going to be volume by displacement, water displacement. You're going to be displacing the water, changing the level that it's at. This is for when you have irregular objects. We're going to do a couple of these examples in this little worksheet thingamajigger right here. And just to let you know, some of these objects, I mean, you can even look at it. You have like an egg in this one, an apple, an orange, a carrot, etc. So these are going to be irregular objects. A rock is even irregular. So let's pretend we have a couple graduated cylinders. So for this example, I'll go ahead and use red or whatever orangey color this is. What you're going to do is take the initial volume and you're going to subtract it from the change in the water level. So, and don't forget, like, whenever you have a graduated cylinder, there's something, and sorry, my drawings are terrible, but if you have like this curve area where the water line hits, you always want to go at the bottom of the curve. So the bottom of the curve is known as a meniscus, and you want to make sure that you measure always from the bottom of the curve of the water in that cylinder, okay? Sometimes it's like the water playing tricks on your eyes in a way, but just know you measure from the bottom. So anywho, in this example, and I don't really love the words on here, so just kind of don't pay attention to the words here. We're just going to do it off to the side, what is I recommend you do. So the initial volume I have here, and if you notice on these problems, it's like number lines in math. They're not always the same. They will change by problem. So you really have to pay attention how you're counting by, okay? It's not always going to be ones. It's not always going to be twos. It's not always going to be threes and so on. It will change by the problem. So we have 5, 10, and 15. But if you notice, we have lines in between. So if this is, let's just practice with 1, see if that works. So 1, 2, 3, 4, 5. Okay, yeah, that's going to be good counting. So this one's pretty much at the 4. I think you guys kind of saw that. So our initial volume will be 4. I kind of mess it up when I write on here, so just kind of note before I kind of write, because the pen can get kind of thick on this screen, so it kind of messes it up. But, so I have this line, and if you notice it's 10, 11, 12, 13. So you always put the bigger number on top, okay, which is usually the one with the object in it, and we're going to subtract. For water displacement, we're finding the change in the water level, so that means change in, that's going to be subtraction. So 13 minus 4 is going to be 9. If you heard that, that was Coach Baker in the background. He knows I'm recording a video for you guys. So hold on one second. I'm going to, just because I want to show you guys, I'm going to pull up the calculator and show you, because I know some of us are better with calculators. So remember on the previous video, I showed you how to add your calculator. And now that you have it, you'll just type in 13 minus 4. And, well, look, we got our answer. That's going to be 9. Okay. You know, sometimes, in all honesty, you're going to have the answer where teachers will tell you milliliters, or if you put C, sorry, that was a C, CM3, that's fine too. For the purpose of this video, I'm probably just going to do milliliters, but just note either or is acceptable. So let's move into this problem. I'll change my color to green. The initial water level, I mean, it's clear on this one. It's a 5, so we'll put 5 over here. And then the water level, once we put that apple inside, it rose to 10. This should be an easy one for you all. So most of you can tell me what 10 minus 5 is. So 10 minus 5 is 5. Awesome. So we're going to go ahead and write that. And milliliters. Perfect. Now we have another irregular object. We put it inside, and it's this orange. The water level, I mean, it's going to be similar to this first example. It looks like we're counting by ones. I can even like count it and see. But this is 6, 7, 8. So we're going to write off to the side 8. Then the water level rose to 10, 11, 12, about 12. So we're going to subtract those two. And then we have 12 minus 8, 4. But remember, in science, we can't just have a number as our answer. We always have to have a unit of measurement, okay? So like I said, we're probably just going to use milliliters, okay? I'm going to go ahead and change the color again. We'll go this pinkish color. For this example, you can see like, whoa, the one's way up here. So that means we're counting by like point something, if we think about a number line. So we're going to have 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1. Awesome. So that works. So if you counted this, this was about 0.7 or 0.7. And then it rose. So this is about, what, 1.1? Awesome. So now we're going to subtract those two. We'll put up our calculator. And it's 1.1 minus 0.7 equals 0. Oh, let's write it up. Can I move this? Here. Let me kind of move it up a little bit. So it's going to be about 0.4 milliliters. Awesome. And sorry, my handwriting's terrible. I'm not really used to doing this on a computer screen, but I'll change the color because I kind of wrote into that next one. So let's go back to blue. For this one, you see we have a 10 here. So we could count by ones, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. So this is about 6. Yeah, so 6. And then the carrots inside and the water level rose to about 9. So 9 minus 6. 9 minus 6. And that's going to be 3. 3 milliliters. Awesome. Okay. Then we have this last example, and I'll switch my color again. We'll jump to, hopefully that's red. We'll see. But we'll jump to this one, and if you notice, we have 1, 2, and 3 on our number line. The original water level, we're probably going to be, well, it's not going to be by ones. It's not going to be by point, like 1, 0.2, 0.3, maybe by 0.2. So 0.2, 0.4, 0.6, 0.8. Yep, that's going to work. Okay. So this first water level is going to be at 2.4. Then we put the object inside. It rose to about 3.4. Okay, I think you guys can see that without doing a calculator, that it's going to be a 1 as our answer. If not, use your calculator. And then we're going to do milliliters. Awesome. Okay, so sorry, I was filling in my notes because I have to show you notes at the end of these series of videos, just kind of a little helper note thing. But anyways, just kind of let you know that's how you do volume by water displacement. And then length times width times height will come up more when we start talking about density. But that's it for this video. And yeah,